Hello, my name is Ninad Sabnis, registration number 18BC1211, and my topic is image interpolation. Image interpolation is something that occurs when you want to change the size of your image. If you want to zoom into an image or zoom out of an image, we are interpolating that image. Image interpolation works by using the known data to estimate the unknown data. This is done by using the information stored in the current pixel, that is to say the surrounding pixels, to estimate the value of the pixel which is not there and we are inserting. Uh, Image interpolation works in two directions. That is, we can zoom in or zoom out, which is also known as upsampling or downsampling of the image. There are many algorithms to interpolate an image, and they are broadly based in two categories: adaptive algorithms and non-adaptive ones. Adaptive algorithms uh, use one part of the image, not the whole image, as a basis for estimation, whereas non-adaptive algorithms are not so particular in their choice of pixels and use the entire image. The similar concept is applied in global and local thresholding. Global thresholding uses the entire image, whereas local thresholding uses a part of the image. The non-adaptive algorithms are nearest neighbor, bilinear, bicubic, spline, sync, langzo, etc. Uh, and and they are used while downsampling or upsampling the image uh, based on how the image is shown to be in the output, if it turns out good or not, while using less memory. Downsampling. Now, my particular topic in image interpolation is downsampling. Downsampling of an image is shrinking of an image or zooming out. Now, this can happen if we want to reduce the dimensions of the image. This means that the unimportant information in the image is removed, and the image is made smaller. A few rows or columns in the image matrix are lost, and we need to downscale images for various reasons. A few reasons are it makes data uh, smaller, it is used to compress the image, and it reduces the dimensionality of the data. And therefore, by scaling down an image, we may reduce its size, but its quality also reduces. There are a few algorithms which are used for downsampling of an image. They are bilinear and bicubic algorithms. These are a type of algorithms which work by interpolating pixel color values, introducing a continuous transition into the output even when the original material has discrete transitions. Although this is desirable for continuous tone images, this algorithm reduces contrast in a way that may be undesirable for line art. So bicubic algorithms gives good results, but with an increase in computational costs. Other algorithms are sync algorithm. In sync algorithm, in theory, provides the best possible reconstruction for a perfectly band limited signal. In practice, though, the assumptions behind sync resampling are not completely met by the real world digital images. The next algorithm that is used usually is MIPMAP. Um, a MIPMAP is a prescale set of downscale copies. When downscaling the nearest MIPMAP, is we use like a pyramid algorithm. We choose the correct map of the image so that it is downscaled to the correct value. The cost of this algorithm is in memory. It uses more memory, one third more than the standard implementation. But the algorithm is fast and easy to optimize. Another algorithm is box sampling. In box sampling, we consider the target pixel a box on the original image and sample all pixels inside the box. This ensures that all input pixels contribute to the output. The major weakness of this algorithm is that it is hard to optimize. This code that I have written shows the rescaling and downscaling of an image which has been imported from the SK image library of Python, and the downscaling is performed by using CV2 algorithms and importing the CV2 package. So this rows, columns, and channels variables are the variables which store the uh, sh- uh, length, breadth, and the color channels of the image. This is the first algorithm that we use for resizing the image. In this algorithm, for initially we calculate the aspect ratio. The aspect ratio is basically the ratio of the width which we want to the width of the original image. We need this ratio so that we multiply the length of the image with this ratio to get the scaled image. Um, we do this using the dimensions inside a tuple. We store the dimensions which we want. The first argument is the length, and the second is the breadth of the original image multiplied by the aspect ratio. And we resize this image using the cv.resize function of the cv2 package. The first argument is the original image array. The second argument is the dimensions tuple, and the third argument is the algorithm which we are using for interpolating the image. In this case, we're using inter area. The inter for downscaling images or shrinking the images. This algorithm takes up clusters of pixels in the image, and then take calculates its average value, and based on the average value it re then the average value is actually the pixel value now, and the surrounding pixels are removed, hence the number of pixels get reduced. That is how the inter area method works. Next we do the same thing, but this time the algorithm used is intercubic. It uses a bicubic function which I talked about before, and this is used to downscale the image. And similarly, I lastly show the interlinear algorithm with used to downscale the image. This uses the bilinear function. uh, both of them both of these algorithms work by uh, introducing a continuous transition into the output, even where the original material has discrete transitions, which means that contrasts are removed, which kind of reduces the quality of the image in certain cases, uh, and hence this resampling will reduce the quality, but and it will also require computational cost, but it will reduce the size of the image, and it will compress it a little. Next method that we use to downscale an image is the pyr down method of the OpenCV package, and this method applies the Gaussian pyramid and the Laplacian pyramid methods to uh, reduce downscale the image. Image pyramid is a collection of images, all arising from a single image, which is the original image which you are using, and these images are successively downsampled until some desired stopping point is reached, which is the smallest possible image. There are two kinds of image pyramids: Gaussian pyramid, which is used to downsample the images, and the Laplacian pyramid, used to upsample the image. In Gaussian pyramids, every layer on the top is smaller than the layer below it, and every layer that we climb up, we make the image smaller by removing the even numbered pixels, even number row or height in our image. And in this way, the image size is reduced and the image is downscaled. But obviously, we are losing information on the image, and so the spatial resolution of the image is not as good as it was before. I have provided different dimensions in the different methods so that they can be easily discerned in the resulting output of the code. So firstly, in enter area method, we have given the width as 200 pixels, so it is the smallest one. Next, in the enter cubic method, the width is 300 pixels, and in the interlinear method, which interlinear method is generally used for upscaling, hence I have shown it last, the width is 400 pixels. So these are the methods that are used to change the dimensions of the image. Also, in the final method, which is pyr down, I have reduced the image to half its size by using the pyr down method of the OpenCV package. And in all these images, downscaled images, the quality is reduced. Also, the size is reduced.